The following video is on the surface area and volume of pyramids and cones. Just a reminder from last week when we were talking about prisms and cylinders. That surface area is the sum of the area of all of the surfaces, which we defined to be faces of a solid. And remember, the surface area for prisms and cylinders was 2b plus pH. Let's just make sure we understand why that is. If we're counting the area of this cylinder, we have two bases plus a rectangle. And so in this case, we had two circles plus a rectangle. And this represented the perimeter of the base, which was the circumference. And then this was the height of the figure. So that would be h. That would be the circumference or the perimeter. So that makes sense. That represents a rectangle. Likewise, over here for a hexagon, we have the same situation, or the hexagonal prism, we have the same situation. We have two bases, so we find the area of two bases. So we would find the area of these hexagons. And then we add that to the area of this rectangle, which is the perimeter of the base times the height of the figure. So it makes sense. I mean, this represents a rectangle, and then we have two bases. So it clearly makes sense. The lateral faces are rectangles. We add it all up, we get one giant rectangle. This pH kind of makes sense. Now let's go into what we're actually talking about today, pyramids and cones. So we're going to focus on surface area in this video, and we'll focus on volume in the next one. Surface area is the sum of the area of all of the surfaces of a solid. So pyramids and cones have one base. Because they have one base, our formula is going to be a little bit different. And if we take a look at how some of these shapes take hold, for example, this square pyramid here, if I look at this, the base is going to be a square. And all of the other shapes are triangles. So I have four triangles that end up being there when I unfold it. In a cone, my base is a circle. So as I unfold this, I have the circle, and then I have something that's not quite a triangle, but in practice, we basically end up treating the area of this kind of like it's a triangle. It has a triangular shape almost. I mean, it's clearly not a triangle, but it's kind of close to a triangle. And so what we have is we have these shapes that have one base, and then everything else are all lateral faces, are triangles, or in the case of the cone, they're like triangles. So we either have real triangles, or in the case of the cone, it's something that's very similar to a triangle. So that means our formulas are probably going to be a little bit different. So let's talk about the surface area of a pyramid. We have one base, so we find the area of the base, which is B, and we add that to, well, if you notice, these are all triangles. So our formula should probably look something like a triangle. 1/2 base times height is the area formula for a triangle. So if I add together all of the bases of all of these triangles, notice that all of the bases of all of these triangles ends up representing the perimeter of the base. Likewise, over here, the curvy base of this sort of triangle is the perimeter or circumference of the circle. So we have 1/2 perimeter of the base. Then these heights need to be accounted for. So we're going to do 1/2 perimeter of the base times I'm writing an L. That's kind of weird. Okay, so slant height. So that's something that's kind of important in these problems. If I have a square pyramid, and this is going to be a very poor drawing, um, but if I have a square pyramid, I actually have three different things that may kind of look like heights. Two of them are things that are kind of important, and then one of them we never really use in calculations. First one is called the edge. So that's one of the actual things that you would touch on the side of the triangles. If I'm looking at the net, this would be the edge. We never really use that in calculations. Then I have what we will call the regular height. That goes from the peak down to the center of the base. That is not used in surface area calculations. It's used in volume calculations, but it's not in surface area. Then we have what's called the slant height. The slant height goes down the edge of the triangle and forms a right angle on this face. So all of these heights of these triangles are actually called slant heights. We give that name L. We call it cursive L. So that's what slant height represents. The same thing happens in a cone. This to the middle would be the regular height. And then this on the side, you may think that's an edge, but since it's circular in nature, we don't really have any edges. So this is the slant height L. So surface area of a cone is likewise exactly the same area of a base, which in a circle is pi r squared, plus 1/2 perimeter of the base times the slant height. Well, remember, in a circle, the perimeter is the circumference, which is 2 pi r. So 1/2 times 2, well, that the 1/2 and the 2 cancel out. So we have pi r L. So if you want the surface area of a cone to have a special formula, there it is. Now let's quickly do some calculations. So we're going to find the surface area of this figure. And just like last time, we have a three-step process for finding the surface area. One is find the area of the base. Two is find the lateral area, which is the area of everything except the base. So in this case, it would be finding a bunch of triangles, 1/2 perimeter of the base times the slant height. And then three, add them up. Now notice in this problem, there's only one base, so we do not have to multiply by 2 like we did in pyramids and cylinders because this only has one base. So if I look, this is a square pyramid, and I would be told that it's a square pyramid in the problem. So the area of the base is just 10 squared, which is 100 centimeters squared. Then the lateral area is 1/2 perimeter of the base times the slant height. So since it's a square, all these things are 10. So perimeter is 40 centimeters. So that's 1/2 times 40 times the slant height. Unfortunately, we don't have the slant height here, so I need to find it. Notice that this actual height is 12, and the actual height goes to the very center of that square. Well, the very center of the square, we know the apothem or apothem of a square is just half the length of the side. So that's 5. So now, if I'm looking at, I could actually draw that either way. So I can draw it to this side, and that may actually help me out a little bit in terms of the visual. So now when I draw my slant height, I see that I have a right triangle, and I can do the Pythagorean theorem. So this is something that's unknown. So that's slant height. I have a 5 and 12 and an L. So 5 squared plus 12 squared equals L squared. So we'll have to do the Pythagorean theorem. When I solve the Pythagorean theorem, I get L equals 13. So I'm going to put that here. 1/2 times 40 times 13 is the same thing as 20 times 13, which is 260 centimeters squared. So then I add together B plus 1/2 PL. So I add these two things together. And I get 360 centimeters squared is the surface area of this square pyramid. Now let's do a cone real quick. The circumference is 14 pi feet, and the slant height is 25 feet. So the slant height's 25, and then they tell me that the circumference is 14 pi. Well, the circumference is all the way around. So if that's the circumference, and I want to find the surface area of this, first thing I have to do is figure out what the radius is. So the radius is if 2 pi r is the circumference, and that's equal to 14 pi, I can solve this for r by dividing both sides by 2 pi. So 14 pi divided by 2 pi gives me 7. So the radius is 7. So now the area of the base is 49 pi feet squared. And then I have the 1/2 perimeter of the base, or circumference, times the slant height. That's 1/2 times, well, they already told me that the circumference is 14 pi, and the slant height is 25. So 1/2 times 14 times 25 gives me 175 pi feet squared. So B plus 1/2 PL is 224 pi feet squared. So I get 224 pi feet squared, and I can type that in the calculator and get some rounded decimal approximation if I want. I would get 703.717 feet squared, and that would be the surface area of my cone.